I'm Dan Slepp. I'm the CEO and founder of ChemCubed. We are a research and development manufacturing company for materials for additive manufacturing. I've been in the field in the printing field and coatings and nanocomposite field for almost 30 years now. Basically, we started ChemCubed around 6 years ago, recognizing that there's a need in additive manufacturing for specific materials, and the off-the-shelf materials right now in additive manufacturing and 3D printers and such would not suffice. Next slide, please. We realized in our research in the last, at the beginning, is that there is a humongous gap in electrical manufacturing of PCB boards, including flexible electronics, regular rigid boards, and flexible hybrids. So we've went ahead from a materials point of view and started developing some materials to cover this gap. At this point, I should say why we're pitching here. And we just won a phase 1 award for AFWorks, and we are looking to get an MOU with a Air Force partner or Air Force customer. We're also looking to expand our innovation and our technology and a lot into marketing, which I'll go into in a minute. So the problem right now is that the current technology of PCB board printing is not widely adapted, only for maybe some rapid prototyping. Next slide, please. So what we've despite just our materials, or including all our advanced materials, which I'll get into in a minute, we've developed some advanced printing technologies and commercialized it. We've had tremendous success with our printing on multiple surfaces and printing circuit boards, multi-layer circuitry, using a printer that's built specially for us, using our materials. We've recently signed on about 8 reps across the country in the U.S. We've got distribution now in the Asia Pacific Rim, and we do have printer sales out in Europe. So we've got about 20 plus of these printers out there. We have more printers than our nearest competitor. I'm going to also say that our nearest competitor printer cost is around 10 times the cost of our printer right now. But again, there's this gap. The printer is a standalone printer. It's great for prototyping. And what we're looking to do is to advance the printer to make it a little bit more usable in a full production line. Next slide, please. But what really stands us apart, and what we are mostly, is a materials company. We've originally developed some silver conductive ink that, there's a lot of silver conductive inks out there. Ours is a nanoparticle free ink. It has near bulk resistivity, centers at very low temperatures, so it could go on multiple substrates. With our printer, reliability of circuitry is down under 1%. I'm going to say that we've had our inks evaluated by numerous customers in aerospace and automotive. We have these printers are bought by some automotive companies and second and third tier companies to the defense. And we are currently actively working with Boeing, and Boeing is interested in being a phase 3 customer when we get there, and have some other proposals into different areas for the government, where Boeing is taking the lead with our technology. One of the other
seconds.
That's fast. One of the other items we have that's very important is our dielectric inks and insulating inks, which allows which is completely compatible with our conductive inks, and that's what allows us to do multi-layer printing of conductive circuitry. Next slide, please. And we go through a number of different applications and what this printer is being used for, including IoT. You can see the flexible hybrid and displays and packaging. Wearables are big, and we're now beginning to get into the semiconductor manufacturing industry as well. Next slide, please. What we're looking to do is build a full system from beginning to end in our AFWorks proposal to upgrade our printer and putting it in a full manufacturing line. So if there's any Air Force people here, we would love to hear from you. But we're going to be putting an end-to-end manufacturing line from our collaborators using different types of new SMT technology, which is component placement technology, which will goes at low sintering temperatures as well. So and is extremely flexible. Next slide. So we do understand that there's a tremendous defense need. We just need to get to the right people under security, perhaps for replacement parts, and increasing the lifetime of components and equipment.
And maybe you can round up and finish up with your ask.
So so what we're asking for is partners to expand our marketing, add a lot more, a little bit into our engineering, and bring our printer to full production capabilities.
I think you also mentioned maybe some MOU partner for Air Force, and then further contracting opportunities with the government.
Yes, we are definitely looking for our Air Force partners.
Wonderful. Okay, open up the floor for questions. Any questions for Dana from ChemCubed?
Hey, I'll just throw this out there. It's not necessarily a question, but I'll look forward to a follow-on with you if you don't mind. I'm not from the Air Force. I am from the Army, but we are looking for similar materials, or at least advancements in similar materials for our aircraft. I almost feel the need to say that we have more aircraft than the Air Force, but I'll refrain on inter-service rivalry for the moment.
Well, I definitely would look forward to.
I'm happy that you refrain, though.
Yeah, almost refrain.
A partner that you might want to consider looking to is Oak Ridge National Labs. They have a manufacturing demonstration facility in Knoxville, Tennessee. And if you don't have a way to connect with them, I'd be happy to pass along anything that you'd like to send over.
I would love that. I'd love to be able to connect, send you something, at least my contact information for you to. Yeah,
they're DOE, but you know, I don't represent DOE at all, but we do work with them as well.
I would appreciate that. Thank you very much.
You're welcome.
For your initial iteration, at least with where things are today, is there kind of like a production volume sweet spot that you'd be targeting? Is it, you know, one-off devices, 10, 100, 1,000 PCBs, or something in between?
Right now, we have a proposal with Boeing to manufacture an IoT device, about 400 units within a given amount of time, a few days. So once we get the whole end-to-end system up, we're supposed to be doing about 400 units. So we are looking for small manufacturing, you know, more than just rapid prototyping. We think that the capability and the cost is so low compared to actual PCB board manufacturing where you're, and it's extremely sustainable because you're not doing any sort of copper etching. And the design work that you could do is going to be, isn't as limited as it is with normal multi-layer printing. So we're looking at trying to bridge the gap to true industrial applications.
Quick question on, the end product, Danielle. Is it sort of like 5G ready with, the fabrication like this? Is it like really, really smooth? No signal attenuation or?
Right now on the printing, in the printing area, it is very smooth. When we place a printer right now, we actually have the end user up and running within the day. With just a little bit of training, we do it virtually. We do have a service person there for people who want to have it installed for them and trained there. But within the day, they're up and running and are able to run their production lines and our R&D facility, whatever they're using the printer for. So I'm going to say that part of trying to expand on the printer is to have it put in some fiduciary camera systems and try to upgrade the printer slightly.